Okay, so we have 4 by 4, 17 people. I think there's maybe 1 or 2 more that are supposed to join. Good morning, everybody. This is really strange. It's the first time I've done this. I did not teach in the spring, so I've never taught a remote course before, and so I know a lot of you probably have some experience based on last spring going through a remote course. Like I said, I don't have any experience doing it, so if you guys have any tips or anything, I'd be totally open to that, as we go through these lectures. I've taught this course for a number of years, longitudinal data analysis, and I enjoy it very much, and I have a lot of good data that I've come across that I work with here at National Jewish. So, I don't think I've met any of you other than Yanran, who's the TA for the course, and so she's going to be helping me. She was in the course last year, and so she's going to be helping me grade and maybe help lead some recitations or something, but we're still figuring that out. But at any rate, this is new and weird for me, but I'm kind of, I don't know, at first I was like, I really want to, the face-to-face is important, and I'm hoping to get back to that soon. I'm hoping that this won't last too long, and we'll be able to get back to face-to-face, at some point, probably not this semester, but actually, and I thought about it, it's like, well, there'll be some interesting things and maybe some good things as well from teaching an online course or remote, I should say. So, and I was talking to Gary Grunwald, and, the difference between an online course and a remote course, this is remote, and the difference is an online course, you can pretty much just watch, lectures at your leisure, whereas the expectation here, and probably in other courses that you take, is that you are attending. It's just that you're doing it remotely. So, I am recording the lectures, and, for some reason there's a conflict or something, if the tech stuff goes right, I'll be able to post that, and then you can watch it. But generally, my expectation is that you'll be present, and I can see your face. I think that's kind of important. I mean, there may be conflicts that you may have, and if so, please let me know, and we can work out those details. So what I'm going to do is I'm just going to walk through the syllabus. And did everyone see my screen share? Okay, so so I work at National Jewish Health, and I've worked here for almost 20 years. I've been here, and I've also had an appointment with the Department of Biostatistics. And a number of years ago, I don't know if any of you know this, but the campus actually used to be off of 8th in Colorado, and National Jewish is on Colfax in Colorado. And so I used to just walk down there and teach a course and then walk back. And then in 2008, the Anschutz campus opened. And so great campus, I love that campus, a lot of space. And so I just started going down there, but I'm still working here. So bike everywhere. So I bike from National Jewish, I bike from home to here, and then from here to Anschutz, and from Anschutz back or to home and stuff. So usually take 16th or 17th out there. So now I'm just biking here and then doing this, and So I've worked here at National Jewish for a number of years, and teaching this course has been perfect for me because I work with a lot of data that's longitudinal here or clustered, and the course title is Longitudinal Data Analysis, but really it could be generalized from that to clustered data or correlated data. So it doesn't, when we say longitudinal data, what we typically mean is data collected over time. So we're looking at repeated measures on subjects. That's the kind of the traditional thinking. But really the course could apply to any data where there's clustering going on or correlation between the responses. Okay, and this is sort of a, as you finish 6611, 6612, the methods courses, this is sort of a natural extension. And I know you guys, are probably familiar with mixed models. I think you talk about that a fair amount in 6612. And so what we do in this course is we build on that. Okay, so we're gonna take the first several weeks to review and make sure you're up to speed, and that's kind of half the battle is for me to figure out where you guys are at in terms of your knowledge of general linear models and linear mixed models. And so I ask a lot of questions, and I get a lot of do you remember this? Yes, no, kind of, turn your head this way. Not sure if it's a yes or no. So you guys will have to be pretty vocal with me early on and let me know where you're at. I know that, part of it too is like instructors are different in their emphasis in the way they teach. So even if I'm reviewing something, maybe there's not a downside to that because you're kind of seeing it in a different way. So I don't feel too bad about going over seeing. But on the other hand, on the flip side of that, there's a lot of material to get through. So we have to really be judicious about how much time we're going to spend on things. Because I do want to get to some more advanced material, the more advanced mixed models where we're dealing with repeated measures in 2 dimensions and, hierarchical models where you have 3 or 4 levels, things that you might see in practice that are, messy data that you might come across. I want to be able to teach that as well as, we get into generalized linear mixed models, a little bit on the topics on the right here. I'm going to see, I got this pad and hopefully this will work. I thought it did before, so let's see if give me a second, see if I find okay. I'm going to have to get the Word version of this, I think, to get this to work. All right, so let's look at this. My writing tool, let's see if this. Okay, I'm not sure why it's doing all that. Let's see, let's go over here. Okay, so there might be some awkward pauses. Just get used to it. It just may happen, especially early on. But I have a list of the general topics that we cover in this course. So this first week is going to be kind of a nice, gentle, introduction, and we don't hit the gas really hard on the first week. So we'll talk about basic longitudinal data introduction. That's today, and then we do get into graphs. We'll talk about that on Wednesday. And then we do a review probably for a couple weeks or so. We'll talk about general linear models and, you know, probably things that you've at least touched on, linear mixed models. Then we get into more advanced material, generalized linear models. Gary Grunwald's typically helped me teach a couple lectures on that. That's kind of his area of specialty. When you look at models that deal with non-normal outcomes like binary outcomes or count outcomes. And then how do we generalize that to account for repeated measures? We get into generalized linear mixed models, interpreting parameters in longitudinal models. And then we get into some more specialized topics that are pretty interesting that you all might, you know, individually, depending on what your project is going to be, you might apply some of these methods. Causal modeling, missing data. How do we deal with missing data in longitudinal studies? Missing data can be a big issue because in longitudinal studies, you know, you may, or experiments, you may have subjects that participate and then for some reason they drop out. So the question is, how do we deal with that? Spatial statistics, and even spatial temporal statistics, Markov chain, Monte Carlo, MCMC. Gary may teach a day on that. Non-parametric and flexible regression modeling, measurement error models. So those are the general topics that we cover. On the Canvas, I have, looks like most everyone's logged in. If you go to modules, there's course notes. That's essentially the textbook for this course that I've developed over the last 12 years or so. So,
hey, Matt.
Yes.
These are actually hidden from us right now.
Okay.
So all of modules we can't see.
Let me see if I can change that right now. This is pretty big, so I think it's just slow. But at any rate, once I get you access, then you'll have access to the course notes here and the slide sets that I walked through. So let me see what's going on here. Does anyone know publish? Probably have to publish it, right? That's probably it. Let me know if that gives you guys access.
That worked. Thanks.
Thanks for mentioning that. Okay, so it's a big, you know, it's a lot of pages, like 400 pages or so. So this is essentially the textbook for the course. So you don't have to purchase a textbook. So that's the positive. But, you know, depending on who you are and what you like to do as far as, you know, how much reference material you want, you may want to get a hold of another text. This is not a requirement. So I think most people that are in the course don't get another textbook, but if you do want more material, I have a list of some textbooks that are pretty decent for this course. And I should have some of these. Hold on just 1 second. So two of the pretty good textbooks, there's one more actually. So So the one that I actually used the first couple of years is this one, longitudinal data analysis. It's kind of funny because there's like a number of textbooks, for this material. There's longitudinal data analysis, and then there's, analysis of longitudinal data, and then there's applied longitudinal analysis. So they just kind of changed the order of the wording. It's a new textbook. So this one here, this is a good one. This was by Fitzmaurice, Laird, and Ware, and it's pretty comprehensive. It's like 700 pages, and it's a really good textbook. I don't expect you to get it. I'm just saying, if, some of these might be in a library, or DU has a pretty good library. So you might be able to find one of these textbooks that will help you. But going back to this one, by Hedeker and Gibbons, this is actually one that I used initially. It's not as long, but it's a decent conceptual book. So those are the number 1 and number 2 on the list. And then there's another good one by Verbeke and Molenbergs that focuses on mixed models. So if you want a reference that gets into more detail specifically on mixed models, there's that one. There's probably other ones out there, but if you have any questions on that, you can let me know. Just ask me. So I'm assuming that everyone in this course has had 6611, 6612, and have most of you, if not all of you, had the theory sequence, the 66, 31, 32? Or is anyone in there right now taking those now? Okay, so everyone had those last year?
I didn't. The
I didn't
PhD,
either.
yeah, the PhD EPI program doesn't require the theory class.
Okay. So there are 2 of you that haven't had it, and you're EPI, you're both EPI?
No, I'm pharmaceutical outcomes research.
Okay.
PhD.
And I'm EPI.
Even I didn't had, I'm a computer science engineer, so I'm in the data science track, so I didn't have this one, 6631.
Okay.
And
So-
I
Didn't have it either.
I took the 02 and 03 classes, the applied biostats versions.
Okay. And somebody else just spoke, Osiemo.
Yeah, I didn't have it either.
Okay. And are you biostat, or are you in another program?
No, biostats.
Biostats, okay.
Yeah.
So you had 11, 12, but not the theory yet?
Yeah, not the theory, yeah.
Okay. So this course is, I think obviously it helps you if you've had 31, 32. There are some theory pieces. I really try to make this course a pretty good mixture of theory and applied. The first homework you'll do, there's a couple questions that kind of they require some theory knowledge, and so if you don't have that, don't get too alarmed. I would say I do want you to have kind of a basic level understanding of theory and some of the properties. But as we go through the homeworks, I think what you'll see is early on, in the first 1 or 2 homeworks, there are a few theoretical questions that you do have to apply some theory techniques. And, we will make sure that you have the tools that you need in order to answer the question. So for some of you, it's going to be more of a review, and for others that haven't had the theory sequence, it's going to be, it may be new. I mean, it may be stuff that you learn now. Either way, it's good. If it's a review, then it allows you to kind of strengthen your foundation. If it's new, then you're learning stuff that really we want you to know, and whether you're biostats or not, I think, you know, if you're epi, if you're in other types of programs that are, you know, that involve some kind of quantitative side to it, these are good theory techniques that you need to know. So there'll be a couple questions probably on the first 2 homeworks that do require it. Don't freak out. If you see these questions like, I just don't know what's going on, I need some help. And so we'll get through those. And then beyond that, like the homeworks 3 and on, it's gonna start being a little bit more applied, where you have some data, you fit a model, you know, whether it's a mixed model or something, you fit the model and you interpret the output, and then you have to write some material and turn it in. So it's going to be kind of more on that end as the course goes on. So that's just to give you kind of a general feel right now. So the course objectives and so forth, I'll let you guys read that. And then there's other, you know, obviously, you know, the way that we're teaching now, you know, the academic conduct policy and the honor code, those things are very important. But you guys are, you know, graduate students, and typically we don't have to worry too much about those things. There may be other documents that I'll post, because I've been getting emails with this kind of thing, and, you know, they've updated them. So I may need to do that. Disabilities, I've heard from 1 or 2 people already, and we'll accommodate you, you know, as we need to. And thanks for letting me know early on if there's special issues that we need to, special accommodations, I should say, that we need for you. So the way that I grade this course, in the past, I think every year I've taught it, I've had 2 quizzes. I like to call them quizzes. You might, you know, I've had students say, this isn't a quiz, this is a test. But I like the word quiz because it makes it seem like it's not as big of a deal. So I'm trying to, you know, make it sound reasonable. And I think it is probably an okay term, because they're just 75 minutes. So the quizzes are just going to be 2 lectures during the course, where instead of having lecture, we do that. And it's relatively short. I make them so that I focus on key material. I'm not going to ask really hard questions. And I've learned that that's not very good for a short test, for a quiz, because then you get hung up on something and you just can't answer anything. So what I try to do is really focus on the core material. So, you know, you can expect a 3-page format. It's obviously, this year's different, teaching remote, but in the past I've actually done a test this way with less resources. Here we can still do the same thing, where we meet online remotely, and you can do your test, you can write it, and then email it to me. And so we'll have 2 days. I'm going to go through the calendar here in a second, and we can look at specific dates and so forth. So there'll be 2 dates during the semester, and then the last one during the finals week. So each one of those is just 12%. So that adds up to 36. The numbers are a little bit weird. I had to do that just to, you know, get these to add up. The homework then is 24%. So that's 60%. Then you have a data analysis project, which I think is really the cornerstone for this class, where you find a data set that's longitudinal and clustered in nature. And you'll be working on this throughout the semester, and then doing a short presentation near the end. And I've taught this, and every year I've really enjoyed seeing the different projects that students work on. And the reason why I like it so much is because there's such a wide range of things that people look at, and it really shows you how you can apply statistics to so many different things. And so this data set that you get, it could be from, it could be from a job that you have, so it could be work related. It doesn't have to be though. It could be a hobby that you have. Like some people enjoy sports, so people have done sports related things. A lot of people do things from their work, looking at certain diseases or outcomes and how they change over time. People, had data from Africa and doing studies over there. So different locations, different types of data, I've seen just a wide range of things that that the methods are applied to, and it's really interesting. So you can start thinking about that now. I'm not going to ask you to have a data set. You don't have to worry about finding one this week or next week. Probably, I would say, within about 3 weeks or so. I'll let you know the specifics on that, but just put that in the back of your mind. Start thinking about, data that's, longitudinal data, so repeated measures on subjects, or something that's clustered in nature. Just start thinking about it. If you may have already get some ideas within the first few days. There's some people that really don't know and take some time to figure it out. If you have issues about, I don't know what I'm going to work on, you can talk to me individually about that as well. Any questions up to this point? So I'm going to just look at the calendar real quick here. I think this one I can just do PDF. So this gives you kind of a day-by-day look at what we're going to learn. And so again, like I mentioned, this first week is pretty kind of a nice, gentle, coming out of the summer, and getting the wheels turning slowly and then speeding up. And then we have like 2 or 3 weeks of foundational material mainly on linear mixed models. And then I plan to have quiz 1 on September 28th. So that will it's basically over the intro material and the foundational material, really. So you can think of this quiz 1 as sort of a review, for those who have had 11, 12 or a related sequence. And then we get into the more advanced linear mixed model material for a couple weeks. We get into generalized linear models and generalized linear mixed models. And then a few miscellaneous topics. This, like what's in light blue, I'm not actually going to spend a day on, but it's material that's there for you. It's kind of related to the course and you can read it. I won't plan to put that on any quizzes unless I specifically say something about that. So I wouldn't test you over those unless you hear otherwise. Interpreting parameters in longitudinal models. Then we have the second quiz, and then the last third of the course is, sort of the advanced topics, and then we have probably 3 days of presentations. And so during the presentations, this is not just for you to present, and earn what you're supposed to do in the course, but it's also for your peers to see just the different ways you can apply the methods we've learned to longitudinal data. And so it's really for everybody, not just for the speakers, for everybody. And during these presentations, I really want you guys to ask questions of each other, and I'm expecting that you will ask at least a couple questions over the, you know, not for each speaker, but I would like to have each person ask a few questions, at least a few questions, over these presentation days. And then the last quiz will be during the finals week, either Monday or Wednesday. We can figure out what the best date is for that. Any questions up to this point? All right, so let's dig in. You guys still see everything there? Okay, good. So I'm going to go through the slide set, and I feel like I've kind of missed a few things I wanted to say. What I'm going to do in general is I will have these slide sets posted on Canvas, and I will get them up in advance. So what I'd ideally like for you to do is read through the slide sets before the lecture, you know, and I know how, you know, sometimes it's going to be, you know, you're going to be busy and you might not get to it, but in general, if you can, try to read through the slide sets in advance. These first two are pretty casual, so not as big of a deal, but as we go forward, try to do that. And then I may annotate them and then do an annotated set posted as well. So again, I'm going to have to swap out for the Word version so I can write on it a little more easily here. Pens. What makes longitudinal data different so we need special methods to analyze it? Any thoughts on that? What are clustered data? What are benefits of longitudinal models or models for clustered data? Why are longitudinal methods not used more? So we have kind of 4 open-ended questions here. Any thoughts on any one of these? Let's go back to the first one. What makes longitudinal data different than, you know, other data? Let's say the data that you use in with just a general linear model, like a typical regression model. What makes longitudinal data different?
Your samples may not be independent.
May not be independent? Okay. And so anybody else? Was it the same? I've heard a couple people.
Is it similar to time series data? For example, there is a continuous changes in data, or it is related to something date and time?
Okay. So some answers. Not independent, right? We're dealing with continuous time, in a lot of cases. Was there somebody else say anything there initially?
Yeah, the fact that they're multiple and maybe the time between observations are not like equivalent.
That's definitely true. Could have unequally spaced time, and we need to figure out unequal, let's say, be able to see if I can use all these things here. unequal spacing between time points. That's something we need to address in a lot of cases. We may have equal spacing, like if you design a study or experiment, you may say, I want measurements at 1 month, 2 months, 3 months. But in real life, like even when you do that, like if you're evaluating subjects that are coming in for visits, a lot of times they won't come in on those specific time points. So the question is, how do you deal with the unequal spacing? What are clustered data?
The data already having some kind of groups, or it is already nested?
Yes. Okay. So I like the terms used nested. There's already some natural grouping to the data, and again, this this indicates that the responses may not be independent, just like we talked about in the first one. So there's correlation that we have to address. Okay. So correlation in data. What are benefits of longitudinal models or models for clustered data?
The models would take into account that correlation between sampling units.
Yes, that's one good one. Takes correlation into account. Anything else that you know of? What we're going to see is that you know, when you do inference, what are some of the things that you want to have for good methods?
Make sure that your assumptions are met.
Yeah, that's a good one. I didn't think about that, but you want to make sure your assumptions are met. That's good. What else?
You get robust results.
Robust results, yes. So results that aren't going to be affected by changes like tweaks in the data or tweaks in the model, possibly. That's important. Those are good answers. The ones that I had in mind, as in addition to those, are power and precision. You want estimates that are precise, you know, that are accurate, and you want good power. So you want to be able to, you know, if there's really an effect, you want to be able to say that there's an effect, right? So power is important, precision is important, having a robust model is important, meeting the model assumptions. Those are all good answers for that. And so longitudinal models, so I'm just going to write a few of those notes down. So we can have so I can have power, precision, and then you want robust results, assumptions met. So just by using a longitudinal model, you don't necessarily get those, but those things are important. I think so. Those are good points there. You want all of those. Why are longitudinal methods not used more? Any ideas? And I think what I would say before I want to hear what you have to say, but just based on your experience. So, whatever, you may have limited experience, you may have more experience, but do you have any ideas about why they're not used more?
I think maybe one of the issues may be because in longitudinal methods, you need repeated measures, and getting someone to come in twice for a repeated measure may be difficult.
Okay, that's a good one. So let's say getting data may be more difficult. Right? Anything else?
Sometimes investigators just aren't as familiar with it.
Yeah, that's a big one. So investigators. And what I can tell you from experience, is that a lot of times researchers will actually have a design for a longitudinal study or experiment. So they'll actually collect measurements over time, and then they end up just doing t-tests. Like they'll look at the change from the baseline to the final time point. They'll just take that difference and just end up doing t-tests. And that's not incorrect, but they're not utilizing the data the best way they can when they simplify. So I think that's probably my biggest one too, is when people don't know something, they're gonna go with what they understand. So if they understand t-tests, they'll use that, even if they get more complex data. So I think the thing that we need to do as statisticians and researchers that are familiar with these methods is make the clinicians and investigators that we're working with aware of these more advanced methods and why they might want to use them instead of just using t-tests. So that's one of the things that I need to teach you is like, there's a benefit to using models that use more data, to use these longitudinal models instead of just going with the simpler t-tests. So that's the thing. You need to convince people, well, there's a reason why we want to use these more advanced methods. All right, some good thoughts. So you guys probably have learned in the previous course that the basic types of data that you get can be categorized into designed experiments and observational studies. And the key difference is that an experiment has an intervention. The observational study is the data just arise without any influence from the researcher, okay? Well, basically. So there's the key difference really is that, in a controlled experiment, there's an intervention given. So it could be, if it's a clinical trial, it might be a drug. So you might observe subjects, for a certain amount of time, and then you randomly assign a drug to some subjects, and then other subjects may get a placebo or something like that. So there may be some kind of therapeutic intervention given to at least some of the subjects in the study. And you want to see the impact, the effect of that intervention. So that's the biggest kind of a maybe the most common type of intervention. But there could be others. It's doing something to alter the what's happening to the subjects or objects, so that it's likely that their outcomes are going to change as a result. So you know, you've learned that, but that applies to longitudinal data as well, as simpler data that's not longitudinal. So one of the big things is, what's the difference between time series and longitudinal data? You may have heard the term time series before. And I actually had, in college, I had a year's worth of time series methods. This was back in the 1980s. I got my degree in statistics at Colorado State University. There's a very strong statistics program there. And they had some really, really good time series professors there. But I would say that it was very theoretical, it was very challenging and not very applied, but very good program. You have to give them credit for that. So I had a year of that, and then I started teaching longitudinal, you know, about 12 years ago. And I'm like, well, what's the difference? Is it the same thing? What's the difference between time series methods and longitudinal data methods? So what I'm doing here in these next few slides is I'm sort of making some generalizations and just to give you a feel of the difference. So time series methods generally focus on modeling one process over time. And the focus of time series is on predicting future values of future occurrences. So one example might be temperature. You can see temperature trends, and you're interested in what's the temperature going to be tomorrow or next week. Or it could be the stock market. Obviously, that's a huge one. If you knew what stocks were hot, right, then you make a lot of money. So you can apply time series methods to stocks and stock prices. But what you're doing is you're looking at one process. And when I say process, like thinking in terms of the data that we're going to see, that would be like one subject. You could think of it that way. So you have a lot of observations. You have a lot of times of measurement, but just one process. That's usually what we focus on in time series. Longitudinal methods generally involve measurements on multiple subjects or multiple processes. And you typically have fewer times of observation. So it might be just a handful, like 4 or 5 times of measurement, or even less. Sometimes it could be 3, it could even be 2. So you can fit a longitudinal model to 2 time points. And I've actually done that a lot. You know, the question is, why would you do that as opposed to just taking the difference? Well, in some cases it may not be an advantage, but in other cases it might be an advantage to actually fit a longitudinal model to 2 time points. So generally speaking, time series methods, you have one process, a lot of time points, and you're interested in predicting something in the future. Whereas longitudinal methods, you have a lot of subjects, or at least multiple subjects, and usually fewer time points for evaluation. Okay, so some of the lingo that we use in time series methods, a stationary process is a process where you have observations. You have one constant mean over time. You may see the process vary around that, but on average, there's going to be one value that's not changing. Finite second moment, so that's related to the variance, right? And the correlation between responses at 2 time points does not depend on t for all spacing h. Okay, I'll illustrate that as we go forward. So what I'm doing here on these next graphs is just illustrating time series data. So we have, you know, some response, and then, so on the x-axis we have time, or t, and we have some generic measurement that we're taking over time. And this process is stationary because generally you're not seeing a trend going up or going down. It's not moving around. It's staying stable. You may go up, but eventually if you go up, you're going to come down. So it's on average, it's this process has a mean of 0. It has a constant variance, and things are pretty stable over time. That's basically what we're saying with the stationary process. So you could have a stationary process with correlated errors. And you guys are probably familiar, if you had 6612, you probably talked about the AR1 process, autoregressive, first order autoregressive process, and that, so I still have this, looks like that. So here we're saying that the error on day t is some fraction of what it was the previous day, you know, as long as phi is positive. That's how you can interpret it. The error today is some fraction of what it was yesterday plus some noise. So z has a normal distribution, some so mean 0 and some variance. So what happens if phi is closer to 0? What is that saying about the process if phi is closer to 0?
Does it mean that the mean will be nearly 0?
Yeah, the mean. So the mean is 0, and the mean would be 0 regardless of what phi is. So so the mean is going to be 0, and that won't be affected by what phi is. But let's say phi, for some process, we see phi and it's pretty close to 0. What is that saying about the data or the process?
They're independent.
Go ahead, Matthew.
It means that it doesn't really depend that much on the day before because the day before is weighted so low.
Right, right. So it doesn't depend on the previous day. So it's saying that the process is pretty uncorrelated. The responses are pretty uncorrelated from each other. Whereas when phi is close to 1, then there's a strong dependency on the day-to-day responses. So that phi is actually the measure of correlation. So the way I worded it the first time was, I was just saying it's some fraction what it was yesterday, but it's actually the correlation between responses on day t and t minus 1. Okay. So a few notes on AR1 processes. The errors are they're identically distributed but not independent. Okay, so that's some terminology. If you had the theory sequence, you know, you probably hear a lot of IID, right? IID meaning independent and identically distributed. Well, in this case, with the AR1, they're identically distributed but not necessarily independent. You know, if these, unless phi is 0. So to have stationarity in the AR1 process, the absolute value of phi has to be less than 1. And the higher value of phi, the absolute value of phi, the higher degree of correlation between responses from day to day. So this is just simulating some data. If we have phi of 0.25, so there's some correlation there from day to day. You really don't see it with phi 0.25. You really don't see it too much. when you raise phi to 0.5, you start to see it a little bit more. 0.75, you're seeing it even more. And then in the last one, I have phi of 0.99. And there you can really see kind of a drag in the function. So if it starts going high, it takes a while for it to come back down because of that high degree of correlation it has on the previous day. Okay, so there's more drag to the function. But if it's a stationary process, what do you know about this?
Will it still have an expected value of 0 for stationarity?
Yeah, that's right. So you know that so the mean, I've generated data with the mean 0. So that's horrible, but that should be straight. So what do you know? You've seen it go down here, but if it's a stationary process, what do you know that's going to happen? Will this thing take off? Could this thing take off and just keep going down? Well, in real life, we don't know, right? But if I'm generating from a model with the AR1 process and the mean is 0, then what do I know about what's going to happen to this function if I keep going, if I keep generating data here?
It'll go back up.
Yeah, at some point it has to go back up. It has to have mean 0. And so it may go down for a while, but at some point it's going to come back up. So if it's a stationary process. In real life, you know, what happens is that we have trends in the data. So what I did here is I generated data using this function. So I have some intercept value, and I set the intercept to 0, and I set the slope to negative 0.05. So that's forcing it to go down. And so that we have the AR1 errors. So we still have some correlation between responses from day to day, but we also have a trend. In this case, the trend is that it's going down. Okay, so I could take the same thing, and what would it look like if I had phi of 0.9 or 0.99? What would this function look like?
Would you expect it to be like more or less linear with a constant slope?
Yeah, it would still be linear. So, and that's an important point, is that we increase the correlation, you would still have that same trend. So the trend would be moving down, but there would be drags to it, like we saw in the first example. It's just that it would be kind of angled, right? So it might go up for a while and then go down, but it would be, it would still have this direction to it. So it might be, you know, something like this, where it'd hover above for a while, maybe hover below, like that. So you'd see more of a drag, but it would still, on average, it would still be going about that line. So some real life data. These are global temperatures, and it's mean corrected, so that's why, you know, we see it at, why is it, you know, from negative 0.5 to 0.8. So they took some long-term average and they subtracted that mean. And so these are temperatures over the 20th century. And so we see a trend where the temperatures are increasing, and then right around 1940 or so, it seemed to stabilize for a little while. And then you see the increase again. And then where are we at now? Well, you're actually going to look at this data for one of the homework questions, but the temperatures are still increasing. And so this is a process. The question is, what you're going to look at in your homework is, does the AR1 process fit this? Once you account for, there's an obvious trend here, right? This is not a stationary process. So there's an obvious trend. But once you account for that trend, and that could be done in different ways, then, you know, will the AR1 errors be a good fit? Is there sort of a drag from year to year in that function once you account for the mean trend? You guys will look at that data. This is pretty interesting. I talk about random walks in the course notes a little bit. I'm going to jump over that so you guys can read that. If you have any questions, let me know. Sorry about these emails. I know what I could do. Let's do that. All right, so what I'm going to talk about for the remaining time that we have, most of the remaining time, is just some of the different data sets that I've worked with at National Jewish. So there, you know, as far as observational studies, we have retrospective observational studies, which means that you decide to do a research project and you're going to get data that already exists. So you're going to go back and look at records and try to dig up things and do a study based on that. And I've done a few of those here at National Jewish. One of them is a long study that the occupational medicine group has been involved with. And so we looked at the natural history of beryllium disease. So beryllium is a metal that's created in certain plants. And for example, Rocky Flats, if you guys are familiar with the history of this area, there was a plant just northwest of town called Rocky Flats, and they used beryllium metal in creating bombs. And that plant is now closed. Okay, people were very concerned about this plant because of radiation and so forth, and it's been closed for a number of years. And I think they're actually, you know, they developed some residential areas not far from it, and they've done a lot of testing to make sure everything's safe now. But so they've used in creating the bombs, they use beryllium metal, and so in the construction, they're cutting the metal, and so that it becomes airborne. So the beryllium gets in the air, and they realize after some time, you know, if people breathe this in, that that's associated with a unique disease that they ended up calling chronic beryllium disease. And so the workers from the plants, so Rocky Flats is one plant. There's others, you know, so other plants across the United States, and for whatever they were using using this metal to make, you know, when workers would become sick, they would come in and get tested. And so we would evaluate their lung function and the exercise physiology measures and so forth, and monitor that over time. And so we compared people that actually came down with this chronic beryllium disease were compared to people that were just sensitized to the metal. And so we were comparing those two groups, but it was all based on just looking back at records. and just evaluating that over time for a number of outcomes. There's, National Jewish Health, this hospital opened up in the late 1800s. And the reason that it first opened was it was a hospital for people who had tuberculosis. So in the late 1800s, they realized that our climate here is fairly sunny and dry, and is actually a healthy climate for people, trying to heal from tuberculosis. So that's really the reason National Jewish started many years ago. These days, we don't do that much TB research anymore. We've done a little bit, especially with subjects that have drug-resistant tuberculosis, so the more extreme version of TB, for the strains that have become resistant to drugs. And so I did do one study when I first came here that involved looking back at records of people who had TB, and then did they take drugs, did they have surgery, and then what happened to these people. So a lot of the modeling was actually survival modeling. And that's one of the things I want to point out is that in this course, survival data is data collected over time, but we don't really do survival methods in this course. So that's something you probably will learn in another course, whether you have already or not. But survival methods are kind of set apart, at least from the course that I'm teaching this fall. So I'm not going to be able to get through all these studies, but another study, a big one that I worked on, involved kids that went to a school. Here at National Jewish, there's actually a K through 8 school, was called the Koonsberg School, and that's the Mortgage Academy. And we looked at subjects, these kids, and evaluated them over time, and then also tracked the air pollution. So from day to day, we're looking at changes in air pollution, and seeing how their health outcomes correlated with that over time. So that's based on a study that we did from 1999 through 2008. So it was a 9-year study, a very big one. We've got a number of papers out of that, and hopefully help the understanding of how air pollution impacts the health of children with asthma. So that's a prospective study because we planned to, there was no intervention, but we planned to look at these kids ahead of time. So there was a plan about when we're going to collect the data, what we're going to collect, and so forth in advance, and then we collected it, but there was no intervention, so that's why we call it a prospective observational study. COPD gene is a big study that I work on that's looking at people that have chronic obstructive pulmonary disease, and we're trying to understand what are the risk factors for subjects that have COPD, and then eventually we're going to study the genetic makeup, to better understand maybe who's more at risk of progressing more quickly, and then how can we target certain individuals in therapy. So there are a number of other data sets, interesting data sets. This one is interesting. Has anybody been to the sand dunes? Okay, I see a few nods. So the San Luis Valley is where the sand dunes are in south central Colorado. It's a very pretty area. If you have not been there, I'd encourage you someday to consider visiting. It's a really interesting area because it's a very flat, elevated valley, but it's surrounded by some tall mountains, especially on the east side of the valley. The Sangre de Cristo Mountains are on the east side. Very beautiful area. But we looked at particulate matter suspended in the air. and how this related to the health of the people in the valley. And a lot of it's not like particulate matter that you would see in a city. This particulate matter is based more on very small particles of sand, or the agricultural farming that they're doing there. So PM is particulate matter. It's actually matter. It's not a gas, and so PM10 would be particulate matter less than 10 microns in diameter. We also look at PM2.5, and we want to see this particulate that's suspended in the air, how it's related to people, the health of people in that same area. So this was what we call an epi time series study, because we're looking at hospital counts. We don't have specific subject data. We have hospital counts over time, and we have pollution measures over time, and we're doing it at a more generalized level than a subject. And so this falls into a class of what we call it epi time series study. I've also worked on some clinical trials here at National Jewish, and basic science experiments where we're looking at samples from blood or biopsies, and we're looking at samples at a cellular level to see potentially the impact of a treatment on how it changes things at the cellular level. And I'm giving some examples of that as well in these slides. So I'll let you guys read through those in more detail. You may actually be familiar with this data set from 6612, myostatin data. You guys familiar with that one? Okay. So we are getting close. I want to make sure that I get to the last few slides here. This is a sleep study where we're looking at, this is actually an experiment where kids were, they were, in 1 week, they were required to have a short sleep week, so they had less sleep 1 week, and then they had longer sleep the other week. And it was a crossover, so subjects were randomly assigned to the order. So maybe some had the short sleep week the first week, and then the long sleep week, and then some had long first. And our interest was finding how this impacted their health. Okay, so we're looking at FEV1, a measure of lung function. We're looking at asthma symptoms for the subjects, and so it's a crossover, but we also have repeated measures. So we have 5 measurements within the first period, and then 5 within the next period. So there's actually 2 levels of time. Period is 1. That's the general level of time. Within a period, though, we have 5 days of measurement. So we're going to look at more closely in the future, how do you model that type of data? It's crossover design, crossover data, but we have repeated measures within each period. So that's another, sleep data is also common here at National Jewish. I'm going to jump down to, well, this is kind of fun, but I'm going to jump over that. When you have a baby, you go to a pediatrician and you can see where your kid is, in percentiles, if you have a boy or a girl. That's kind of fun when you're a first parent. So what you're doing is you're going to track your kid over time, and what you're looking for is consistency, right? If the kid is at the 5th percentile, let's say the kid is at the 95th percentile when they're 5, and then the next visit, they're at the 5th percentile, that would be a flag, right? Because what you're looking for are changes over time that it could indicate maybe something's going on. So the thing that I want to make sure I talk about is I think what I'm going to do, I'm switching gears. Since it's 10:15, we're pretty close, and I don't want to just kind of rush too fast. I think what I can do on Wednesday, I'm going to go through the last few slides here. So again, if you can, walk through these slides and then also the graph slides. So these are on Canvas. Just take, you don't have to spend a lot of time. Just spend maybe 15 minutes or so going through these slides. I'm going to go through the last few of these from this slide set, and then I'm going to talk about graphs, and we'll be fine getting through those on Wednesday. So I don't feel like I need to rush. So we're going to pick up next time. We'll pick up, I think, roughly on 28, and we'll finish those up, and then go to the other set. So any questions at this point? I don't have any homework posted yet, but I'll do that fairly soon, and it will probably be due, since we have a short week next week, it'd probably be due the week after that. So I'll try to get that up maybe by Wednesday or so. Thanks everybody. Thanks for your participation. It seemed like it worked out pretty well. If there's anything, just be vocal. If you see like earlier, if something's not working, let me know as soon as you can. Or if you have any thoughts or suggestions. And be waiting to see you on 9 o'clock Wednesday. So have a good couple days, and we'll talk to you on Wednesday. If you need to let me know anything on an individual level, just send me an email. And see you Wednesday.